Good morning students, this is Shilpa Sirasya. Today in this video we learn about the Mealy machine. As we know that there is a finite state machine who generate the output. So there are two types of machine, Mealy machine and Mealy machine. In the Mealy machine that we know in the previous video that output is depends on the present state. Okay. While some differ from the Mealy machine, in the Mealy machine, it is an FSM finite state machine whose output is depends on present state and input. While in the Mealy machine, it is only depend on the output is depend on the present state. While in the Mealy machine, the output is depends on the present state as well as input. So the formal definition, as it constructed with the 6 tuple, same like a Mealy machine, Q, sigma, O, delta, X and Q0. As Q is a finite set of states, sigma is a finite set of input alphabet, O is a finite set of output alphabet. As Mealy machine generate the output, so from given input we have generate the output with the different alphabet. So that is comes from the this output alphabet. Okay. Now delta is an input transaction function, that is Q cross sigma to Q. X is an output transaction function, that is Q cross sigma to O. In the Mealy machine we know that output is depends on the present state and input. So present state and input, then we get the output. While in the Mealy machine, that Q to O. In the Mealy machine, it is Q to O, that is output is depends on the present state only, and Q0 is nothing but the initial state, which is one of the set. Okay, now how to construct the Mealy machine? So we take the same example so you can understand that what is the difference between Mealy machine and Mealy machine, how the difference construction from between these two. Okay, so the example is same, that we print the output A when we encountered 0 1 in the binary string. Okay, so before that we just in the Mealy machine we write something like that. Suppose this is a state and the output of that state is X, so we represent something like this, that in the state A the output is X. Okay, while in the Mealy machine, as it says, the output is depends on the present state and input. So when we go to one state to another state, okay, with the input 0, okay, so the output is depends on the state as well as input. So we generate the output something like this. With the state A, we go to the state B with the input O and we generate the output X. Okay, so like suppose we take an example of we generate the ones complement of the binary string. Okay, suppose our string is 0 1 1 0 1. Okay, so the output is 1 0 0 1 0. Okay, you see that how construct the Mealy machine of the same. We have to construct the ones complement. Okay, so in the Mealy machine it is simple. Like we start with this one. Okay, if there is a state A, if we have an input 0, then output will be 1. There is no any another requirement of the state or something. Okay, with the one state and input we generate the output. So we say that if it is 0, then output is 1. Okay, from this state, if the input is 0, we generate output is 1. Same way, if we give the input 1, output 0. So here it is a Mealy machine of ones complement that generate the ones complement of the binary string. Okay, now we come to our example. So this is for how we write the input and output and all. This is the input and this will be output. Okay, so as the basic structure is same like the FA, or we are in generating in the Mealy machine. So it is a 0 1, then it gives the output A, or others it's B, like 1 1 1 0 1 0 or 0 0 or nothing, null. Okay, so we always start with the whatever the fixed value, that we continue with the first. Okay, so 0 1 it gives the A. So 0 then 1, 0 then 1 it gives the output A. Only 0 it's B, 1 it's B, 1 1 1 it's B, 1 0 B, 0 0 B, 1 0 B, 1 1 B. Okay, so only 0 1, that is A. So how to construct the transaction table? That we have a state A, B and C. Okay, so if it is an input 0, then we go to the next state as well as with the output value. Same way, input is 1, we go to the next state with the output value. So in this example, from the state A, if input is 0, then we go to the state B. Okay, and output is this B. Okay, from the state A, if we give the input 1, then output state is, next state is A, and the output is B. Same way, from the state B, if the input is 0, then the next state is B and output is B. From the state B, if give the input 1, this one, okay, we go to the next state, it's C and the output is A. For the state C, if we give the input 0, the next state will be B and the output is B. Same way for the 1, next state is A and output is B. So this is about the transaction table. Thank you.